This is section 2.5, which is creating and solving compound inequalities. So this is going to be part 1, and we're going to start off by graphing an inequality on a number line, which is review from Math 8. So the first problem is graphing on a number line x is greater than 6. And before we kind of get into that, I want to remind us about what the signs mean and what type of dots we would want to use. So if we have a less than or greater than sign, we're actually going to use an open circle, which represents that it does not include that point. If we have a less than or equal to or greater than or equal to, we use a closed circle to represent that we do include that point. So we're going to start off with x is greater than 6. So we're going to draw a number line, and I'm going to be pretty lazy and say that's 0, 1, 2, 3, 4, 5, 6. Because it's just x is greater than 6, I'm going to do an open circle. And then to represent things that are greater than 6, I shade everything that is bigger than 6. So a lot of students like to use the trick knowing which way the arrow points. Because it's pointing to the right, we shade to the right. But that only works if x is on the left. So for example, in the next one, according to that arrow trick, we'd want to shade to the left, but that's actually not correct. So if you'd like to always use that trick, what I would do first is make sure the x is on the left. Notice that the sign is facing towards the x. So all I did was just kind of rewrite it. So again, draw your number line. I have 0, 1, 2, 3. I'm going to use a closed dot, which represents that the answer includes 3. And then I want to shade everything that's greater than 3, which would be everything to the right. Okay, so the next one is a your turn problem. So go ahead and pause it and try it on your own. Then I will go over it. So for this problem, we have x is less than or equal to -2. So draw our number line. I have 0, -1, -2. And I'm going to do a closed dot because it's equal to. And I want to represent things that are less than or equal to -2, which would mean shading everything to the left. All right, the next one is our main point today is studying compound inequalities. We're going to be looking at and or inequalities. A compound inequality is just combining two or more simple inequalities. And we are going to look at and or. Okay, so our first one is an and inequality. So when we think of the word and inequality, we are going to think about how that means like intersects, or a lot of people like to just say it means between. And this will make a lot more sense once we kind of get moving with this. So here we have two different compound inequalities. So you'll see it's a compound inequality because it has two inequality signs. So our main goal is to isolate the variable. We're going to kind of treat the inequality signs like equal signs, even though there are two of them. So in order to isolate that x, right now I'm subtracting 4, so I'm going to go ahead and add 4. But what we actually have to do is we have to add 4 to all parts of the inequality. So that would get rid of the 4 in the middle. I would have -2 plus 4, which is 2. I would bring down my inequality sign. I have my x in the middle, bring down my inequality sign, and 3 plus 4 is 7. So then I would draw a number line, and I'm going to have, we'll say 0, 2, 3, 4, 5, 6, 7. So what this answer actually means is that x is between 2 and 7, which means any number between 2 and 7, including 2 and 7, makes this inequality true. So to show that it's including or equal to, I'm going to do a closed circle at 2 and a closed circle at 7. If the inequality signs confuse you, you could always just write them separately. So I'm drawing it facing the x for the 2, and then it's away from the x for the 7. So it's representing x values that are greater than 2, which means we'd shade to the right, and less than 7, which means we'd shade to the left. So in reality, we're actually just shading everything in between. So anytime we have an and inequality, you just shade in between. All right, this next one, again, we want to isolate that x. So the first thing I want to do is add 1 to all parts. So I have -5 plus 1, which is -4, is less than 2x, which is less than or equal to 3 plus 1, which is 4. We're still working on isolating that x. So the next step would be to divide by 2. So even though I have a negative number and I'm dividing by a positive number, I don't flip the sign. The only time you flip the sign is if you had a positive number or negative number and you're dividing by a negative number. So in this case, we are safe. So I'd write -2, because -4 divided by -2, or divided by 2 is -2. I bring down my sign, and 4 divided by 2 is 2. So I draw out my number line, and notice I just brought down the signs exactly how they were. At -2, the sign is just a less than sign, so I'm going to do an open circle. At +2, it's an equal to, so I'm going to do a closed circle. And then I want to shade everything in between. If you are confused, you can rewrite them. Remember, x, I know it's going towards the x, is greater than -2, and x is less than or equal to 2. So it's bigger than -2, but less than or equal to 2, which would be everything in between. So numbers that make this solution true would be 2, 0, -1, but numbers that would make it not true would be things like -3, -2, 5, so anything outside that shaded region. Our last thing is an or inequality. So or inequality is going to be meaning going away from each other. So it would be greater than a big number but less than a small number. So the nice thing about an or inequality, it gives it away because it'll say the word or. So it should be pretty obvious. So how you solve these is you actually just treat them like separate inequalities, okay? Looks like oops. So we're just going to treat them like separate inequalities. So for the first one, I want to isolate that x. So I'm going to go ahead and add the 3 to both sides. So I get x is greater than 4. So that one's done. On this one, I'm going to add 2 to both sides because, again, I'm trying to get that x by itself. So that cancels out, and I get x is less than or equal to -3. And then I bring down my or. So I'm going to draw my number line. I have 0, 1, 2, 3, 4, -1, -2, -3. So at 4, I do an open circle because it says x is greater than 4, so it's not including 4. At -3, I do a closed circle because it says it's less than or equal to -3, so that means it includes -3. And then I'm going to shade. So since it's less than or equal to -3, I want to shade everything that's smaller than -3. Since it's greater than 4, I'm going to shade everything that's greater than 4. So or is always going away from each other. So things that will make this inequality true are numbers like -3, -5, 4.15, but things that make it not true are 0, 1, 2, 3, 4. So anything in between makes it not true. Okay.